Hello students, this is your Professor Dr. Mink, and welcome to the first lecture for Chapter 5, Lists and Loops. Let's get started. This slide lists the topics that we're going to cover in the 2 lectures for Chapter 5, and keeping with tradition, I'm going to break this list in half, and we will cover half of the list in the first week, in which we cover the first half of Chapter 5 and the second half in the second week. So let's get started on input boxes, list boxes, and then loops. First topic we're going to cover is Chapter 5, Section 1, input boxes, which is a new way we'll learn to solicit input from the user. Not necessarily the primary method for input, but one method that we have in our toolbox. An input box is used to prompt the user to enter data, and it provides a text box as part of the input box where values are typed. OK button returns a string value containing the user input. There's also a cancel button returns an empty string. This is not something you use as a primary method of input. It is also very convenient to use for developing and testing applications. Let's take a look in our next slide at the format of the text box. The input box. The input box only has one required argument, which is the prompt. And this is normally used to ask the user for a specific value. Enter an integer, enter a value, enter your name, etc. There are 2 optional arguments, the first being the title, which is a string that appears in the title box. It contains the project name by default, but you can change that property and put a title. And you've probably seen this when an input box pops up in an application, a Windows application that you run before. The second optional argument is a default string that's displayed in the text box. It is empty by default, but you can put a default that says something like enter your text here, would be one example. In order to use the string returned by the input box function, we need to assign its return value to a variable that is declared as a string. Here's an example in the rectangular box of some code that does that. So we declare a string named string str user input, and then that's on the left-hand side of the assignment operator. And on the right-hand side of the operator is an input box in which the user is entering a distance, providing a value. And then the return from that input box, whatever string the user enters, okay? Now, we're asking the user to enter a distance, which would be a double, 24.5 whatever miles. It's probably not enough detail in the input box, but anyway. And then we could try converting to a double the string input and assigning it to a double variable, double distance. The next input solicitation control we're going to cover is a list box, which allows the user to pick items from a list and select them and enter them. This is going to be content from Chapter 5, Section 2, entitled, you guessed it, list boxes. A list box displays a list of items specified by the programmer, and the purpose is to allow the user to select one or more, i.e. multiple items from the list. If the list of items to select from is longer than the list box is sized, a scroll bar will appear and allow the user to scroll up and down the list. You simply double click or drag and drop the list box icon from the toolbox window, position and resize the controls necessary, and the size of the rectangular determines the size of the list that can be displayed at one time. Strongly suggested to use the LST prefix when naming a list box. Let's take a closer look at the items property of the list box in our next slide. The entries in a list box are stored in a property named items, and the items property holds an entire list of values that the user may choose. They select those users, and then they could be inserted into other statements in the program. Here's the unique aspect or property, characteristic, I should say, of a list box. The list of values in the list box can be established by the programmer during design time. In other words, you can populate the list as you're designing the form, or they can be added at runtime. Okay, the items are stored in a collection called the items collection. I've found, I was going to create a video for this, but I found a really good YouTube video already created showing how you add values to a list box at runtime, and I placed the link on this slide. Please take a look at this video before you move forward in this presentation. Next item on the agenda is adding items to the collection during design time. And here are the steps in which you have to follow. But I've created a video using tutorial 5-1. I'll place a link on the slide and back in the timeline session for this lecture. In the properties window, you click the items collection property, and then the ellipsis button shows you the list of values, each on a separate line, that you add at design time. Rather than me spend any more time talking about this, please stop this video and either click on the link here or go back to the timeline and watch tutorial 5-1 running. Thanks. The Items.Count Property returns an integer, which is the number of list box items, or it returns 0 if the list is empty. So you can use Items.Count return value in an if statement. So here's some code. If the list box list employees.items.count equals 0, then label status.text equals there are no items in the list. Or you can assign the integer returned by the Items.Count property to a variable. Obviously, it has to be an int variable, integer, and that code is in the box at the bottom. Int number of employees assigned list employee item employees.item.count. Each item in your list is assigned an index value, and the first item always has an index of 0. This is not the most intuitive numbering system, but it is the way most computer numbering systems work. The second item has 1, third item has 2, etc. So when you assign an item to a variable, you must explicitly convert the item to the same data type as the variable. So here's an example from listCustomers.items number 2, which is actually going to be the third item in the list, sent to the toString method, and then assigned to string name. So you can actually go in and extract the items from the list and then assign them to a variable. In the second example given, list room numbers.item 0, which is the first item in the list. Index 0 is the first item. and we're converting that to an int and then assigning it to a variable called int room number. This slide shows two different methods, both totally correct or appropriate, to handle an exception caused by an index that is out of range. So if there are, and I've seen this happen most frequently when there are 9 items in a list and the code tries to reference index number 9 or item number 9 with the items procedure. And there is no item number 9, even though there's 9 items in the list. Their indexes are 0 through 8. And that's where the zero-based indexing often causes problems at the boundary condition. So this can be done with a try catch block and or with a series of if statements, if else statements. So the first example, try, and we're trying to convert a certain index number, which would be the value stored in index, to a string. Well, if the value of index references a non-existent or appropriate index number, okay, we're going to show whatever message that is. We could also use an if statement. If index greater than or equal to 0 and index less than items count. Now, notice the logic here. It's not less than or equal to items count. So items count will give you the total number of items on the list. Let's say it's 9, but there is no index 9. So we're saying if the index is greater than or equal to 0, it can equal 0. That's a boundary condition, the lower boundary condition, but less than 9. So in this case, it would have to be between including 0 and 8, not including 9. And then we'll generate that error message. The SelectedIndex property returns an integer with the index of the item selected by the user. Now remember, this is a zero-based indexing system, so if the numbering system, so if the user selects the first item in the list, it's going to return a 0. So, and if no item is selected, the SelectedIndex property returns -1. So we can use SelectedIndex to determine if an item has been selected by comparing it to -1. And here's some code that does that comparison. You can see the not equal to -1 and then whatever. The selected items property or selected item property contains the current selected item from the list box. I want you once again to take a close look at the coding in the tutorial I posted for 5-1. On this slide, we have an example of an if-then statement that first checks to see that the selected index is valid. And if that's true, it assigns the selected item property of list items after sending it to the toString member function to a string variable, string item name. Remember, you can't just send the selected item to a variable. It has to be cast to that variable data type first. Another useful list box property is the sorted property. Sorted is a Boolean property, which means it can only be true or false. When it's set to true, the values in the items property are displayed in alphabetical order, and when it's set to false, they're displayed in the default order or the order they were added. And its default value is false. So if you want them sorted, you have to go in and change that because they're going to be displayed in the order that you add them. And that's probably a good default. For example, go back to the months. You wouldn't want to sort the months in alphabetical order because it wouldn't make any sense. It wouldn't be in chronological order. Okay? if you want to add, excuse me, if you want to add values to the item property at runtime, we have to use the Items.Add method, and it will add the item to the end of the existing list. So here's the general format, listbox.items.add, and then the item to be added. And item is the value that we're adding to the items property. And you can add ints, you can add decimals, you could add, I think you can add any of the data types to a list box. If you want to insert an item at a specific index location, you use Items.Insert Method. And what it does is it has two arguments passed to it. The first is the index number, and the second is the item. And so if you have index value 2, and there's, let's say, 7 items, 0 through 6, it places the item argument at 2, and what was previously 2 goes to 3, 3 to 4, 4 to 5, 5 to 6. So it kind of inserts before the current item number 2. As you might have guessed, in addition to the methods to add items to a list box, we also have methods to remove items. And those 3 methods are remove at, and that requires an index as its argument, and it will remove the value at the index specified. I guess I'm sounding like a broken record, but don't forget it's a zero-based indexing system, meaning the first item is not 1, it's 0. So items, listbox.items.remove, and then an item actually removes an item that matches the argument passed to that particular method. And then listbox.items.clear, which doesn't have any arguments, removes all items in the items property. Here we have 3 coded examples of remove at, remove, and clear. And the first one removes the third item. Notice it's at index 2. 0, 1, 2 is the third item in the list. The second, list students.items.remove the string, capital JEAN, removes that item. And list students.items.clear removes all items from the list box. Here we have a nice summary listing of all of the important collection methods and properties for list boxes, and the method or property, its name on the left of the first column, and a description of what it does. Probably a good reference for you to have. I'm not a believer in printing things, but maybe store it somewhere you can get to it as you're programming. Pull that slide out. Okay, next, on to one of my favorite topics, loops, the iterative structure. Let's get started. I often ask students in my face-to-face classes, especially the introductory classes, if they've ever interacted with a loop structure in a computer program. And surprisingly, many of them look at me like I've got 3 heads, and very few of them, if any of them, say yes. But let me just tell you that in our society today, unless you live in a cave, and that would be cool too, but unless you live in a cave, it's almost impossible to go through a day and not interact with some sort of a looping structure. If you purchase items off of an e-commerce site, a website, Amazon.com, whatever, when it asks you to add an item to a cart, and then it asks you, would you like to continue shopping? That is a loop. And if you say yes, it'll take you back to the the function that handles adding items to the cart. If you say no, it terminates the loop and takes you to the function that handles the checkout, etc. So the old ATM programs where you would insert your card and it would hold your card, display a menu, allow you to withdraw, check your balance, transfer, etc. And then asked you, would you like another transaction? And if you selected yes, it would present the same menu again. It would continue to loop. And the body of that particular loop or iterative structure was the menu, the high-level menu option. Now, I've used that example for many, many years, but most ATM programs, because of security reasons, now require you to re-authenticate. In other words, it'll give you one transaction and it doesn't actually hold your card anymore. So some of them still do, but most of them don't. You slide the card in and out, reads a magnetic strip, the card never leaves your hand. It presents you the main menu that you authenticate into, and you get one transaction, and then it logs you out. But anyway, let's get started talking about loops. A loop is a repetitive or an iterative structure that causes one statement or a series of statements, also called the body of the loop, to repeat one or more times. And each time the body of the loop repeats, it's an iteration, referred to as an iteration. Visual Basic has three types of loops: the do while, the do until, and the for next. And the difference among these three is how they control the repetition and when the Boolean condition that determines whether or not to iterate again is checked. First up is the do while loop. The do while loop has two main components. First, a Boolean expression that is tested, and remember, a Boolean expression can only equal true or false. And then a statement or group of statements, i.e. the body of the loop, that is repeated as long as the Boolean expression is true. And they're referred to as conditionally executed statements. Now, one must note that some statement within the body of the loop must change the parameters of the Boolean expression. And if that doesn't happen, the Boolean expression will never change, and we will have what's called an infinite loop, never ending. The first example we're going to look at for a do while loop is what falls into the category of a count control loop. We have a counter. So let's take a look real close at the code in the rectangular box. We're declaring an integer variable called int count, and we're initializing it to the value 0. And then we have our do while statement, and then we have our Boolean expression, int count less than 0. I'm sorry, int count less than 10. Now, obviously, the first time we encounter int count less than 10, int count holds the value 0. 0 is less than 10, so that will resolve to true. It will return a true. So while that's true, list output.items.add hello. So it's going to add the string hello to the list box. And then note, that's the first statement in the body of this loop. The body of this loop has two statements. Notice what the second statement does, and I referenced this in the previous slide. It increments the counter. So int count equals int count plus 1. So the first time through the body of the loop, int count will go from 0 to 1. So we are in effect changing the Boolean expression, or one of the items in the Boolean expression. So int count 1, we're going to come back up. We hit the end of the loop statement. We come back up to the do while. 1, int count now has 1. 1 less than 10 is true, so we add another hello, string hello, to the list output.items. Then int count gets incremented by 1 and it becomes 2. 2 is true, another hello. It gets incremented to 3, 4, 5, all true, 6, 7, 8, 9, all true. Now, when it goes to 10 and comes back up and it evaluates the Boolean expression, do while 10 less than 10. 10 is not less than 10. If it were less than or equal to, that would be true. 10 less than 10 resolves to false. So we skip over to the first line of code after the end of the loop. So in this particular case, because the integer started at 0 and we continued to return a true until it got to 9, and when it got to 9, so 0 through 9, we actually added 10 hellos to the list output.items using the add procedure, but we never added for 10, but we actually added 10 items. So if you think back to the indexing number, we added 0 through 9 in index locations 0 through 9, and we actually added 10 items. Had we started our counter initialized at 1, this would have only added 9 items at index 0 through 8. I made reference to an infinite loop, and here we're going to discuss that in more detail. The loop has to have some way to end itself. And in the previous example, we had a count-controlled loop where our counter value, I believe it was int count, approaches the boundary of 10, okay? 0, 1, 2, 3, and it's getting closer to the boundary condition, which is actually when int count equals 9. That's the boundary. And then when int count equals 10, it goes from true to false. So we have to have something within the body of the loop must eventually force the test expression to false. Now, let me tell you, count-controlled loops are not the only category of loops that we can encounter. There are some loops that ask before iterating. In other words, would you like another transaction is asked from within the body, and then the user selects yes or no, and then that value is compared to a string yes or no to determine whether or not we want to iterate again. Next item of interest is the counter. The counter, which we've seen and discussed in the last 2 slides, is a variable that is regularly incremented or decremented each time a loop iterates. So to increment the counter means to add 1 to the counter's value each time the body is encountered. And by the way, we can increment by 2, we can increment by 3, but the most common scheme is to take an integer counter and increment it by 1. Decrement means to subtract 1 from the counter. And we could have structured the previous do while loop, set our counter to 10, and have it decrement by 1, and the Boolean expression would be y counter is greater than 0. And that would still give us 10 iterations with a decrement counter. Okay? Here we have a very important component of do-while loops, which is whether they are characteristic, I should say, whether they are a pretest or a post-test do-while loop. Okay? The previous do-while loops are in pretest form, which means the expression, the Boolean expression, is tested before the body of the loop is executed. In a pretest loop, it's possible that the body will never be executed because if the Boolean expression returns false the first time the loop is encountered, or the first time the Boolean expression is tested, we will never execute the body of the loop. The do while loop also has a post-test form where the body of the loop is run through or executed before the expression, the Boolean expression, is tested the first time. And the body will continue to repeat as long as the expression is true. A post-test, the differentiating characteristic between a pre and post-test loop is that a post-test loop always executes to the body of the loop at least once. So even if the Boolean expression, the first time it's evaluated, returns false, in a post-test loop, we've already run through the body once. Now we're going to take a closer look at coded examples of these two, so just hang in there. So we've already looked at the pretest version of the do while loop. Here is the post-test do while loop version. Okay. Instead of do while, then the condition, and then loop at the bottom, we just put do, and then the body of the loop, a single statement or multiple statements that are executed, and then the word loop, and then the while Boolean expression at the very end. This functions similarly and can execute the body the same way the do while loop, the pretest do while loop is, except for there is no condition where the body of the loop will not be executed at least one time. By the way, we talked about ATM programs and the old ones where you stuck your card in, and my students tell me they're still around. It holds the card and it presents a menu where you perform your first transaction. Let's say I check the balance of my savings account. It gives me my balance. Then it asks me, would you like another transaction? And if I select yes, it presents the same menu of options. That is a post-test loop. I don't necessarily know that it's coded as a do while in Visual Basic. I did know many years ago that the code for the ATM machines was written in C++, but I've lost track of my contact in that world, so I can't say that it's in this language or not, but it is definitely a post-test loop. So back to our course. Here we have a coded example where we're declaring an integer int count and we're initializing it to the value of 100. We have do, the body of the loop, message box.show hello world, and then int count equals int count plus 1. So we're incrementing the counter. So this will this will display the message box with hello world in it one time, and then we get to the loop statement and the while Boolean expression, int count less than 10. Well, the first time through, think about what will the integer int count hold, what value will it hold? Well, during the body of the loop, int count got incremented by 1. So int count will equal 101. While int count 101 less than 10 returns false. 101 is not less than 10. So even though the first time we encounter the Boolean expression in this do while loop, because it's a post-test version of the do while loop, we still executed the body of the loop, the message box.show hello world, and the incrementer, counter incrementer, at least one time. I've assigned 5-3. It's a real quick tutorial that takes tutorial 5-2 and modifies it to use a post-test do while loop. It's in the timeline. Take a look at it. It's fun. Well, I thought it was fun. One of the most common tasks required or calculated within a loop is keeping a running total. Use it for score, sales total. If you're constantly adding items to a cart in a shopping application, it's looping and it's adding the value or the cost of each new item to the cart. So this calculation requires a loop that reads each number in the series and then accumulates the total called the running total. we use a variable called an accumulator variable to hold the running total, because we typically use one variable to solicit each new value, and that variable is reused. Let's take a closer look. Here's the flowchart showing the logic for keeping a running total. And one of the things you need to do is you need to both declare and set the accumulator to 0 before you start. If you just declare it, the first time in, before the accumulator has not had any values added to it, you'll be trying to use an uninitialized variable, and you'll be trying to add the first number read into the accumulator, which will give you an error. So the best way to do that, the only way to do that really, is to set the accumulator to 0. We go into the loop. Is there a number? Is there another value to read? Yes. Read the number and add the number to the accumulator. Then we go back up. We check, is there another number to read? That could be a count controlled loop. It could be looking for the end of file. It could be, there's various ways of controlling that question or coding that question. Here's a fully coded post-test loop that accumulates a total. So notice we have a constant int number of days, 5, and int count is declared and initialized at 1, decimal sales, decimal total as a decimal equals 0, string input is a string. So here's our do, and then we want to get the daily sales amount from the user. So we assign to string input the return from input box, enter the sales per day, and int count to string. And then we parse. We use the try parse method to convert string input to a decimal. And if that works, we add decimal sales to decimal total. Now, decimal total is the accumulator. And notice up where we're declaring our variables, we also initialize that to 0. If that wasn't initialized to 0 the first time we tried to add decimal sales, which will have a valid value in it, to decimal total, we'll get an uninitialized variable being used error. Let's increment our counter from 1 to 2. Okay. Obviously, if the if try parse fails, we're going to prompt them to enter a number, and we're going to continue to loop while int count is less than or equal to int number of days, which is a constant declared at 5. Take a close look at this. Just take a minute and digest this. This is your first real look at a fully coded do-while loop. That's the end of our do-while loop. I'd really like you to complete tutorial 4-5, which uses the code we just saw in a pretest form as part of a more complete solution. And then tutorial 5-5 demonstrates how to structure a loop so that we're not specifying the number of iterations in a declaration initialization statement, but instead prompting the user to specify the number of iterations, which is very simple, but something that we should explore. Next, we're going to cover the last section of the textbook for the first lecture of 2 for Chapter 5, and that's the do until and for next loops. And these are easier to understand now that you've seen the basic structure of a loop and you understand what the body is and what an iteration is and what a Boolean condition is. So let's take a closer look at these. Next, we cover the do until loop, and there is a slight but significant difference in the structure or syntax of the do until loop. It continues to iterate until an expression turns true. So it repeats, it iterates each time the test expression is false, and it stops when it's true, which is the opposite logic used with the do-while loop. And it obviously, or not obviously, but it similarly to the do-while loop, it can be written in either a pretest or posttest form. So let's take a look at the pretest and posttest. Pretest, do until and the Boolean expression and the statements or statements that make up the body, and then the loop keyword. Or the posttest version, do and then the statement or statements which make up the body, the loop keyword, keyword, and then until and the Boolean expression. I've provided a link to tutorial 5-6 running, which demonstrates a pretest do until loop. Please take a look. I'm placing the link here and in the timeline. Next up, no pun intended, is the for next loop. Another iterative or looping structure. It's very good to use this for count control loops because it has a built-in counter in it. So in this case, let's take a look at the box or the rectangular box. For keyword int count equals 1 to 10. So this is going to iterate 10 times. And each time, messagebox.show hello. We don't need to manually increment the counter. We don't need to code int count plus equals 1 in the body of the loop because the for loop does that automatically. So let's walk through each step or component. Int count is set to 1, which is the start value. Int count is compared to 10, the end value. If int count is less than or equal to 10, we continue to step 3. The messagebox.show hello statement is executed. So that's the body of this loop, okay? Otherwise, the loop is exited, okay? So this is just an abbreviated, more efficient way of doing a do-while count control loop. And here is, keeping with tradition, here is the flowchart of the logic for a for next loop. Next, we're going to cover the for next loop. Sorry. So we set the int count to 1. We go into the Boolean expression, which is implied int count less than or equal to 10. If yes, display hello, add 1 to the int count. So all of this automatic counter management is built into the for loop. And we continue until the Boolean expression int count less than or equal to 10 becomes false, and then we skip over the body of the loop and move on to the next statements in our program. In the for next loop, the default step value or increment of the counter is 1. But we can change that by using the keyword step and another integer value. So, for example, we have a coded example here where we're starting int count equals 0 to 100, and we're stepping by 10. So this will still increment 10 times. But the counter, int count, will go from 0 to 10 to 20 to 30 to 40 to 50 to 60 to 70, 80 to 90, 100. Actually, as I'm thinking about this in my mind, this will actually increment 11 times because we're starting at 0. And the step value may also be negative, causing the loop to count downward. If we want a by 1 increment, in other words, decrement, we still need to use the step keyword because remember, the default is an increment of the counter plus 1 each time. Here we see the use of the for next loop to calculate the sum of a series of numbers. And in this particular case, we're going to use the counter. So we're declaring int count as an integer, int total as an integer, and because it's an accumulator, we're setting it to 0. and we're going to add the numbers 1 through 100. So for int count equals 1 to 100, int total, which starts at 0, plus equals int count. So each time, int total will have the value of the counter added to it. So it'll start at 0, and then we'll add 1, and we'll add 2, we'll add 3, I'll add 4, and it will end after the series of numbers between 1 and 100 are added together, and will then display the sum of the numbers using a message box. There are some instances where you need to end a loop before the Boolean condition would end it naturally. And there are two statements to accomplish this. Exit do is used in a do while or do until loops to exit regardless of the Boolean condition, and exit for is used for for loops. You want to be careful with this because it does bypass the normal loop condition testing. But let's just say you're looking for a specific sentinel value in a series of numbers, and if it's encountered, you want to stop. So you'd have to put if the current value equals, and then exit do or exit for would accomplish that. But like I said, it makes a loop more difficult to code and should be used with extreme caution. Last slide in this section, and also in the first lecture of 2 for Chapter 5, helps us to decide which loops to use in which circumstances. So, although I will tell you, take this with a grain of salt, because you could make almost any of these looping structures work for a specific circumstance. It just comes down to which one is better suited, more convenient. So the do while loop, when you wish the loop to repeat as long as the test expression is true, or at least once as a pretest loop. You use the do until loop when you wish the loop to repeat as long as the test expression is false, or at least once as a pretest loop. And the for next loop is primarily used when the number of required iterations is known, and that's called a count control loop. So I hope you've enjoyed this section. Loops are one of my favorite topics. I know that makes me an official nerd, but I just think they're wonderfully useful, and I enjoy coding them. And I hope you enjoy them also. So obviously, if you have any questions about any of the content of this lecture, you know how to reach me. And I know most of you have been reaching out and asking questions, and that's great. Also, that extends to any of the tutorials or the assignments in this chapter. So thanks again for watching. Have a great day.